Mark is 12, 13, 14, 19, 23, and 25. That's the homework. This section goes along with 8384. It doesn't get much easier, but just stick with it, I would say, is a little hint. The 8.5 properties of logarithms. It's right there. Learn how I can simplify and evaluate expressions using the properties of logarithms, and then I can solve logarithmic whatever equations using the properties of logarithms. So the first property is the product property. And the biggest thing from here is you need to remember and understand this. Now when you have a number, you can break it into two parts and you're adding that. So a times b equals log base x a plus log base x b. To show you a couple examples from that, a really basic one. So the first example we'll put on the side. Really basic one would be log. I'm just going to use, they tell you that log 4(3). This is what this means. So this is the decimal. So to give you a quick little example, we have log base 4, 9. How can I get 3 from 9? 3 times 3, right? So log 4(3) plus log 4(3). That's what this property is doing. It allows me to break 9 into 3 plus 3. From there, I know that log 4 base 4(3) equals 0.7925. So now I have 0.7925 plus 0.7925, which this equals to be 1.5850. So that would be your final answer then. 1.5850. One quick thing with logs. Little star here. If I had to say log base 5, anytime the big number and the base number, what we call b, are the same thing, the answer here is always going to be 1. Always going to equal 1. So if it's log 4 and then 4, that's going to equal 1. Log 6 equals 1 as well. So do a little bit more of a complex question. We have this first example A. So this is kind of our hint of what we need to get to. We need to get to 3's. Alright. So we have log 4, 192. Now this is where we have to be a little bit creative. We have to think about how can we get 3 out of here. The first thing I would do is take 192, divide it by 3, and you get 64. Why is that helpful? So I have log 4, and this is 64 times 3. Is what do we know about 64 that's cool and interesting? If you check your perfect chart, you then can see that 64 is 4 to the 3rd times 3. And once we have this, remember that little hint I talked about up here? We're going to then use that. Now we're going to use our product rule. We just talked about the product property. And our next step is log base 4 cubed plus log base 4 3. Now log base 4 here is just 1 times 3 then is 3. And then plus, we know what this is, 0.7925. So our final answer is 3.7925. So that's kind of the product property with that. Why was I able to do this? I'll show with the power property. And we'll go back to explaining again why this works. But our next property is the quotient property. And this one, it says if you have anything that looks like this in the beginning, you can break it into the first part, the numerator, subtracting the denominator. Okay, so the example here, again, these are the hints parts. What are the hints for you? And here's our problem. What I'm going to do is use this property like so. So we have log base 4 5 minus log 4 3. That we know what the decimals are there on our left side. So now I know that this is just 1.1610 minus 0.7925. And you use classic subtraction with your calculator, and you had 0.3685. So that's if you have quotients. Now the power rule is interesting. That's this right here. The fact that if you have something to a power, you can just pull it in front of the log, and then it's multiplied with the log. So why is this helpful? Let's go back to that first example. If I pull this now, I really have 3 times log 4 4. So this is just a little side work, which is 3 times 1, which is 3. So that's how we get the 3. That's why that works out so well. Okay? That's this property. Right, let's go flip the page. We'll do some more examples. So the second part is solve equations using the properties of logarithms. So how can I solve these problems? And first off, we have this. Now, if you have logs on both sides, like b, makes it a little bit easier. It goes back to what we did in 8.4 with canceling them out. If you only have logs on one side, you're going to have to do our classic formula from logarithms to exponentials. So first off, if we have this right here is the product property. Remember, if they're adding, we can multiply the insides. So you really have log 6 x times x minus 9 equals 2. Now I'm going to label. So I have b here. B here. This entire thing is x, and there's y. So then, when I flip it to exponential form, I have 6 squared equals x times x minus 9. 36 equals x squared minus 9x. Imagine now that you have quadratics, you're probably going to have to factor. So I subtract 36, and you get 0 equals x squared minus 9x minus 36. Then you'd think, what two numbers multiply negative 36 and add to negative 9? X minus 12 and x plus 3. So x equals 12 and x equals negative 3. Then the last thing you're going to have to do is you're probably going to have to check to make sure these work. So the thing is if I plug a negative 3 into here, I have a log with a negative inside of it. That can never happen, so you know that this is not going to work. And this one will work because you can plug 12 in. 12 minus 3 is log 6 base 3. That will work, but you'll never get an answer. If there's a negative number here or a negative number here, that's never going to work. It won't happen. All right, let's do another example. So this is where we kind of have two properties going along. We have the property, the power property that we can use, and we have product property. Right? So I'm going to work the left side first. This is going to be the product property. This is A. That's B. We can just multiply those two. So we have log 7 81. And on the left side, we have log 7 x squared. Again, with the power property, this can just scoot back up as the exponent. It can go back and forth. But now that we have this is basically a problem that we had in 8.4. So I can cross this out, and you have 8 squared equals 81. You then can square root it, right? How to get rid of a square, you just square root it. Then you have x equals plus or minus 9. So you have x equals 9, x equals negative 9. If you try negative 9, obviously you're going to have a negative number. And when you test this in your calculator, you plug negative 9 here. Again, you can't have a negative number. So the x equals negative 9 doesn't work. But the x equals 9 does.